We want to find the equation of the line that's given in the graph below. Typically, when we're asked to find an equation of a line given in a graph, my default is to use the slope-intercept form. The complication in the graph that we're given is that the y-intercept does not fall nicely on the grid. If we look at where it crosses, the y value of the y-intercept is somewhere between 0 and 1, but I don't want to have to guess or have to approximate, especially if there's no need to approximate or to guess. Because we don't know what that y-intercept is, the slope-intercept form is not going to be a good choice to use. Because of that, we will then switch our attention to the point-slope form. To use the point-slope form, we need to find 2 points on our line. Looking at the graph we're given, I can see there are actually 4 points that fall nicely on the grid. There's 1 point here at -10, -3. There is 1 point here at -4, -1. There's a third point at 2, 1. And there is a fourth point at 8, 3. The first step in setting up the equation will be to determine the slope based off of 2 of those points. Remembering that the slope, the m, is the rise over the run, we need to find 2 points on this graph to find that ratio, the rise to the run, the slope. Using the 2 points identified in the first quadrant, at 2, 1 and 8, 3, I will first figure out what the run is. The run from the point at 2, 1 to the point at 8, 3 would be a run of 3 tick marks. What we need to remember, though, is the scaling on this graph. Since the x-axis is scaled as 2, 4, 6, 8, 10, I need to recognize that this run is not 3 units, but 3 tick marks. And 3 tick marks with that scale would be a run of 6. To determine the rise, I can see that I need to rise up 2 units from where that arrow stopped. Looking at the y-axis, we can see the scale is 1, 2, 3, so that tells us 2 tick marks is 2 units. So therefore, we know the slope m is equal to the rise over the run, in this case, 2 over 6. Because the slope is just a fraction, we can reduce that fraction to 6 down to 1/3. Now that we have identified the slope, we can come up with the equation in point-slope form. As a beginning point, let's remind ourselves that the point-slope form looks like y equals m in parentheses x minus x1 plus y1, where those x1, y1 values come from a single point on the graph. Now, given that we have 4 points that we could choose to work with over there, we do have 4 different versions of this equation we could give. We'll go through 2 examples, leaving the other 2 for you to try on your own. If we were to find the point-slope form using the point there at 2, 1, the point-slope form of this line would become y equals m, which is 1/3, times x minus x1, which is 2, plus the y1 value, which is 1. So we would have y equals 1/3 quantity x minus 2 plus 1. Had we chosen to use one of the other points, say the point there at -4, -1, our equation would still have the same form, but the x1, y1 values that we use would be different. And so we would have y equals the same slope, 1/3, times the quantity x minus this x value. So it would be x minus -4 plus a -1. Now, it would not be typical to leave the equation in that form, meaning we would not typically have minus a negative number in the middle and plus a negative number at the end. Instead, we would more typically write this y equals 1/3 times the quantity x plus 4 minus 1. Again, there are 2 more points on this graph that we could have used, one at 8, 3, and the other at -10, -3, and had you chosen to use one of those 2 points, your answer would still be 100% correct, but it would look a little bit different.